Hello everyone, you are watching my YouTube channel Chemistry by Sadhanvar, and today we are going to solve a past paper challenging question from this paper. Edexcel International. This is A-level chemistry paper, and the question which we are going to discuss in this paper is question number 21. So guys, in 21, the very first part we are going to solve is we are going to skip this because this is a bit easier part. We are going to discuss double I, calculate the pH of the solution of gluconic acid. So gluconic acid and the organic acid, they are the weak acid. So if we have to find the pH of the weak acid, the very first step we need to find hydrogen ion concentration. Remember, hydrogen ion concentration in case of weak acid, hydrogen ion concentration is equals to concentration of an acid times Ka. So, or we can say Ka times concentration of the weak acid under root. So, Ka is given here. So, we have to find the concentration of this gluconic acid. If we can have the concentration of gluconic acid, we can find its pH. Okay. So I guess we need to solve part I first to make our job a bit easier. Write equation for the acid dissociation constant. Ka is equals to, if I write equation RCOOH upon dissociation, it would give me hydrogen ion and this RCOO negative ion. So Ka would be equals to hydrogen ion and RC. First, I can write hydrogen ion. It would be much better. Hydrogen ion concentration RCOO negative ion on RCOOH gluconic acid concentration. So now I have to calculate concentration of solution. You guys, now concentration is equals to moles on volume, and moles is equals to mass upon molar mass. So mass is given here 4.75 gram. Molar mass of gluconic acid is given here 196. So when I divide 4.75 by 196, I would get 0.0242. This is the moles. So once I have moles, I can find concentration by using this formula. Concentration is equals to moles upon volume, and moles is 0.0242. Volume is 250 cm3. And I need to convert this into dm3. Do not skip this. So 250, divide this by 1000, you would get what? You would get answer in dm3. So when I divide 250 by 1000, it would be 0.25 dm3. So here 0.25 dm3. So 0.0242 divided by 0.25, this would give me concentration 0.0968 moles per dm cube. So this is the concentration of an acid. Brilliant. So I can use this concentration as such, I believe, where in this equation. So hydrogen ion would be equals to Ka. Ka is equals to 1.38 times 10 raised to power minus 4. Weak acid concentration is 0.0968. So when I solve this, I would get hydrogen ion equal to, let me plug in values in my calculator. This would be equals to, yes, 3.65 times 10 raised to power minus 3. So this is hydrogen ion concentration. So if I have hydrogen ion concentration, I can find pH. pH is equals to negative log of hydrogen ion. So negative log of hydrogen ion, and hydrogen ion concentration is this. So when I take negative log of my answer, I would get pH. The pH is 2.4. So this is my final answer. Guys, if you have any doubt about this question and how I am solving it, don't hesitate. You can contact me. Now I'm scrolling down below to solve its another part. You can take a screenshot of this and note down the concentration of acid is 0.0968. So I'm writing with permanent pen here. Concentration, just to make it easy, concentration is 0.0968 because I have to erase that now. 1 to 3. Okay. I'm going to skip it. It's easier. This is a bit challenging. 5 marks. Guys, 5 marks question. Calculate the pH of the titration mixture after the addition 35 cm cube of sodium hydroxide solution. A bit data is provided to us in the previous part. We cannot skip that. I am going to skip this curve, but you can see solution of 0.0105 moles per dm cube sodium hydroxide was titrated against 25 cm cube of gluconic acid. So I can note down what they have given me here. I can mention here concentration of alkali is, what was concentration of alkali? 0.105. Okay, 0.105 moles per dm cube. And the volume of acid, gluconic acid given in this part is 25 cm cube. Now let's play with this part. Here they have mentioned calculate the pH. So what exactly we are going to do is, you are familiar with this equation. pH plus pOH is equals to 14. So pH is equals to 14 takes away pOH. So somehow, if you can have pOH, you can find pH. So first of all, we have to find pOH. pOH means we need to find negative log of hydroxide ion. And if we want hydroxide ion, it means we need to find concentration of sodium hydroxide. So if we have concentration of sodium hydroxide, we can have the concentration of hydroxide ion. Once we have the hydroxide ion concentration, guys, then we can have pOH. And if we have pOH, we can have pH. Brilliant. But that is not easy 5 marks. I'm going to solve it. So first of all, calculate the amount of gluconic acid in 25 cm cube, because you have the concentration of acid 0.0968, if I'm not wrong, something like that, moles per dm cube. So moles is equals to concentration times volume. Concentration of acid is 0.0968. Volume is 25. I have to divide this by 1000 so that my answer can be precise, accurate. So 0.0968 times 25 divided by 1000. I'm getting 2.42 times 10 to the power minus 3. This is the moles. So remember this alkali and acid. I'm going to say acid versus alkali. Acid versus alkali, their moles are same, like 1:1 or whatever, their moles are same. So if acid is 2.42 times 10 to the power minus 3, I can say alkali moles is this as well. So I have the moles of alkali. Now I can find volume of sodium hydroxide needed for neutralization. Calculate volume of sodium hydroxide needed for neutralization. Neutralization. You guys know Volume, you guys, now concentration is equals to moles upon volume. So bring volume here. Volume is equals to moles upon concentration. So volume is equals to moles upon concentration. Moles of alkali is 2.42 times 10 raised to power minus 3. Concentration of alkali is 0.105. So volume would be 0.105. I mean, yeah, volume is 0.023 dm cube. Just multiply this with 1000. Your answer comes with dm cube. I mean cm cube. Cm cube. So this is the volume of alkali. You guys can see the volume of alkali is also given here somewhere 35. So the now we calculate the extra volume because they have given us 35 and 23 is the volume of sodium hydroxide needed for neutralization. So calculate excess volume, and that is 35 of the cm cube, like this is also sodium hydroxide volume, takes away 23, so this would equals to 12 cm cube. Perfect. 12 cm cube means in dm cube I can say this is 0.012 dm cube. This is volume of sodium hydroxide that is extra. This volume would help me to calculate excess amount of sodium hydroxide. Calculate excess amount of sodium hydroxide. So to calculate excess amount of sodium hydroxide means moles. So moles is equals to concentration times volume. Concentration of sodium hydroxide is given in the beginning of question. Now the volume is excess volume 0.012. Do this stepwise. This is a bit challenging question. So moles is 1.26 times 10 raised to power 23. This is excess amount. Excess moles amount means moles of sodium hydroxide. Now guys, calculate concentration of sodium hydroxide in the final titration. Means when you add 25 plus 35 together, you would get 60 cm cube. So this is the final volume. Calculate concentration of sodium hydroxide in final mixture. Concentration is equals to moles upon volume. Moles is equals to 1.26 times 10 raised to power minus 3. Volume is 60. 25 plus 35 is 60. And 60 must be in dm cube. So this would 0.06 dm cube. 0.06 dm cube. Remember from where I'm getting 60. 25 is this, 35 is this. 25 plus 35. Collective final volume is 60 cm cube, 0.06 dm cube. So 1.26 times minus 3 divided by 0.06, 0.06. So this would be concentration 0.021 moles per dm cube. So guys, this is the concentration of alkali. This is a strong alkali, so it would give me hydroxide ion. So if alkali concentration is 0.021, I can say hydroxide ion concentration would be 0.21. Okay, yes. So this is the concentration of hydroxide ion, which I can put here. Where here? POH is equals to minus log of hydroxide ion concentration. this one. So take negative log of this. So when I take negative log of this, I would be getting 1.698. This is pOH. So pH is equals to 14 takes away pOH. pOH is 1.698. 1.698. So my final answer is pH is equals to 12.3. So this is my final answer. Guys, this is a challenging question, I must say. So I have tried to solve it. In the mark scheme, they have solved this, but I'm just trying to make it easy for you. If you guys have any further doubt, or if you guys want me to solve any question, DM me, email me, WhatsApp me. I offer one-on-one tutoring session. Don't hesitate to enroll yourself in my one-on-one tutoring session. I'm minimum tuition fee. Thank you so much for watching. I would request to share this video with your class fellows, with your friends. Thank you so much for watching. Have a nice day. Enjoy.